Hi everyone. The next three videos are going to focus on higher order functions, functions that take functions as arguments. There are many well-known, in the right circles, higher order functions over lists. They're super useful and they make list processing a total snap. So we're going to start by looking at filter, and the next video I'll look at map, and then the one after that I'll look at some higher order predicates for determining things about lists. Let's start with filter. Filter says you give me a predicate. A predicate is a function that takes something to booleans. It sort of gives an up or down vote on a given value of a type. So predicates are things like even b or odd b, right? That's a unary predicate. It takes one argument. A binary predicate might take two arguments, like EQ base or EQB for nats or LEB. Those are all binary predicates. So filter takes a unary predicate. You give me an x, and I'll tell you if it's a good one or not. You give me a list L of x's, and I'll give you back those elements of the original list L that satisfy the test in the same order I got them. So we can see that code right here. We look at L. If L is empty, great, there's nothing to filter. If L is some head and tail, well, if H passes our test, then stick H on the front of a recursive call. Otherwise, just make a recursive call. Another name for this function, as you see in maybe the Rust programming language, is retain, in the sense that we want to retain exactly those values which satisfy test. One thing I want to call your attention to is the formatting we've done here. Notice how we've used blank space to make similar parts of the lines line up with each other. This is the sort of thing that programmers do to make their code a little easier to read. It lets you see what the difference is between two branches or two lines. And clean and clear formatting is definitely an art. Programming is a craft, and this is an element of that craft, writing your code in such a way that the viewer, the reader, can quickly understand it. You don't have to stress about it now. We might occasionally leave remarks on your code saying, hey, this was really sloppily formatted, or maybe try doing this or try doing that to make your code look a little nicer. Code looking good is an important thing, and some open source projects even require your code to go through some formatting process before it can even be run. Okay, let's play with this function a little bit, see what we can do with it. So here we have the list 1, 2, 3, 4, and we're going to filter the even numbers out of it. Now I say out of it, that's maybe a little misleading. We're going to filter to retain the even numbers. Filter keeps, right? It's the filter that says pass through a filter that only permits even b to pass through and be kept. Or you could think of it like a sieve, where it's like, oh, here's a filter where everything that doesn't pass even b will fall through the sieve, and I'll keep just these lumps of gold or whatever they are, panning for that. Okay, so if we filter even b, we get 2, 4 out, and you can see, okay, we've retained the order that it came in on. You could imagine a version of this function that, say, reversed it, or scrambled it randomly, or did something like that. I don't know why you'd want that, but you could do that. So it's important to know that, oh, this doesn't permute the list at all. Nothing gets rearranged. It just selects those elements to be retained given the predicate. All right. So you can go pretty far with this. So here's a predicate on lists that says, oh, it's a list of length 1. Right? There's other ways to define this function. You could do a match. You could do all kinds of things. But this is a nice, concise way of doing it. This kind of concision, like once you have a bunch of functions and you start using them to define other things, that gets really nice, I think. So now we could look at this big list of lists and say, oh, let me filter just for the ones that are of length 1. So we'll use this function. When you do that, we'll select 3 and 4 and 8. All the others are of the wrong length. This one has 2 elements, this one has 3 elements, and this one has no elements. So we'll just get out 3, 4, 8. Solid. This sort of collection-oriented programming style where you sort of like, oh, I have a list, let me filter out these and then do this and then do that. We'll see some more functions that are useful for this. Can be really powerful. So like, let's say I gave you the task of count the number of odd numbers in a list. Now you could do that with a fixed point, no problem. You walk through the list, you do the ordinary recursion, okay. If it's odd, you'll return 1 plus your recursive call, otherwise just do the recursive call. But if you know filter well, you could say, that's just the length of filter odd BL. Done. One go, one line. This is the power of higher order functions. There's all kinds of mistakes you could have made if you'd written the fixed point out in full, but now it just gets written down the once. Still better, A good compiler can know about functions like filter and map and be able to produce better code for them, right? It'll sort of know how to work with sequences of filters and maps and do various optimizations to turn multiple loops into one loops. It's a whole area of study. It's pretty fancy stuff. With fun names like list fusion and deforestation and stream fusion. You sound like you feel powerful when you talk about it. But my point is, this is a beautiful way of expressing a computation where we've been able to do it very concisely in a way that reduces errors and might even lead to efficiency gains. So I think that's pretty sweet. Okay, so there's some examples there for you to play with. A thing I want to note is that higher order functions and anonymous functions are BFFs. They go together so well. So up here, we sort of like defined length is 1 as its own function, but we don't need to do that. With our fun and fixed notations, here's a nicer way to do it. This is a one-off function. We, on this occasion, care about a particular predicate, those things which are equal to, those lists whose length is equal to 1. So great, I'm just going to define that function here, not have to give it a name, and pass it in as an anonymous function to filter, and then there you go. That's the whole thing. People who program in functional languages frequently employ this style all the time for quickly specifying what, in an imperative language, would be a loop taking a couple of lines. I think it's a pretty sweet style, and it's a fun thing to play around with. Okay, in the next video, we'll meet another higher order function, and after that, one more, and then we'll do our case study. Talk to y'all soon.